Bismillahirrahmanirrahim. Projectile motion. Up till now, we have been studying the motion of a particle along a straight line, that is, motion in one dimension. Now we consider the motion of a ball when it is thrown horizontally from a certain height, as shown in figure. This motion, which is in the air and it makes some angle with the x-axis, is known as projectile motion, or the motion in two dimensions. Projectile motion is actually the motion through air without propulsion. Propulsion means no auxiliary or extra engine or force is moving the object. It is once powered up or once it is pushed or thrown and then released, and then it moves without any force or without propulsion. Examples: when we throw a volleyball or a simple ball in the air, or a sky diving jump, and a golf ball hit, thrown the ball into the air. Examples: the volleyball flying in the air, or the sky diving jump, a man flying in the air, or a golf ball which is hit by the player and it moves up in the air. All these motions are the examples of projectile motion. Let us consider this figure in which a ball is thrown horizontally by applying a force along x-axis, and then it is released and it moves independently. It moves with the initial velocity vi. At the start, at time t is equal to 0, its velocity is just along x-axis and no vertical component of velocity is there. But as it starts moving and time starts, the gravitational pull start working on it, and that pull, or the force due to the earth, accelerates it towards the ground, as shown in figure. Body was initially moving along x-axis, but due to the gravitational pull, it also starts moving down, and actually it is moving in two dimensions. It is proceeding, or it is moving forward along x-axis and also along y-axis, as this phenomena is further elaborated in this figure. The ball at different points is shown, and the combination or the path of all the points is known as trajectory of projectile. You see, at every point, the ball is actually moving in two dimensions. The ball covers x-axis distance and also along y-axis distance at every point. If we see, at this point, ball has moved along x-axis and then along y-axis. Similarly, at this point, the ball has covered some x distance and simultaneously it has covered some y distance. And further, it moves forward, and at this point, the ball has covered x distance at this point and y distance at this point. And similarly, and so on, it moves with the same behavior. But if we probe and we observe more closely, we can deduce that the along x-axis distance is uniform in each interval of time. It means that the body is covering equal distance in equal intervals of time, or it is moving with a uniform speed along x-axis. But the projection of the ball along y-axis is covering different distance along y-axis in equal intervals of time. It means that body is not covering the same distance and it is speeding up. At the starting interval, it moves slowly, and in the next interval, it moves faster. And in the next interval, it moves further fast, and it is speeding up along y-axis. Actually, due to gravitational pull, it is falling down with the acceleration due to gravity. And you can see it in this figure that acceleration is being observed along y-axis, but there is no acceleration or no speeding up or no change of velocity along y-axis. So motion is accelerated along y-axis, but the acceleration is constant and downward. And that acceleration is minus 9.81, mean acceleration is equal to gravitational acceleration. But the horizontal component of the velocity is constant and the body is moving with no acceleration. The horizontal and the vertical motions are independent of each other, but they have a common time. From this analysis of the projectile motion, we see that along x-axis, the motion is uniform motion with uniform speed, but along y-axis, there is an accelerated motion. And this analysis says that, or from this analysis, we can also describe that we performed this motion under the assumption that there is no air resistance. There is no horizontal force acting on it, so its horizontal velocity will remain unchanged, as according to Newton's second law. We know that when there is no force, no horizontal force acting on the ball or no air resistance, so it will move with zero acceleration, or it will move with a constant velocity, and that velocity is Vx until the ball hits something. The horizontal motion of the ball is simple. The ball moves with a constant horizontal velocity component, hence horizontal distance is given by Vx cross t. The vertical motion of the ball is also not complicated. It will accelerate downward under the force of gravity with acceleration. Acceleration is equal to g. This vertical motion is the same as for freely falling body, since the initial velocity in y-axis is 0, and hence vertical distance from the second equation of Newton's second equation of motion given by the physics is y is equal to half gt square, as initial velocity is 0. The vertical motion of the ball is not complicated. It will accelerate downward under the force of gravity, and hence A is equal to g. This vertical motion is the same as for the freely falling body, since the initial vertical velocity is 0, as the vertical distance y using the equation 3.7 is given by, as initial velocity is 0, so vertical distance becomes equal to half, acceleration is equal to g, half gt square. Thank you for watching the video lecture. Please continue watching our video lectures and please visit the website www.cancollege.com.